For more than a century, archaeologists built an entire story around a single comforting assumption that the people who raised Europe's great stone monuments, the same people who dragged multi-ton boulders across entire landscapes to build Stonehenge, who carved spirals into the entrance stones of Newgrange, who erected silent rows of megaliths across Brittany, were the direct, unbroken ancestors of the people living in those same regions today. It was a tidy story. It suggested continuity, a single thread running from the Stone Age straight into the modern world. And according to ancient DNA, it is almost completely wrong. Somewhere beneath the fields of Ireland, England, and the Atlantic coast of France, buried inside the very tombs those ancient builders constructed with their own hands, scientists have extracted genetic material that quietly dismantles one of archaeology's oldest and most comfortable assumptions. What it reveals instead is a story of migration, replacement, and near-total genetic erasure, one so abrupt and so complete that many of the researchers who first saw the data assumed, at first, that something had gone wrong with their samples. Nothing had gone wrong. What ancient DNA has uncovered over the last decade is one of the most dramatic population turnovers in European prehistory, and it happened right on top of the monuments those very people had just finished building. Let's start with the world these builders actually lived in, because understanding what was lost requires understanding what existed first. Around 6,000 years before the present, across a broad stretch of what is now Western Europe, communities of farmers began doing something no one in that part of the world had done before. They organized labor on a massive scale, gathered stone from quarries sometimes many miles away, and constructed permanent monuments meant to last. Passage tombs in Ireland, stone circles across the British Isles, dolmens scattered through Brittany and Iberia. These weren't quick or simple structures. Some of the stones used at sites like Stonehenge weigh several tons and were transported from bluestone quarries in Wales, roughly 150 miles away, using nothing but human labor, timber, and remarkable engineering ingenuity. For decades, one popular theory tried to explain how such a sophisticated, widespread building tradition could appear so suddenly across such a large geographic area. It was called the megalithic diffusion theory, and it proposed that a single wave of migrating people, sometimes imagined as missionaries or colonizers, carried the idea of monumental stone architecture outward from the eastern Mediterranean, spreading it gradually westward until it reached the Atlantic coast. It was an elegant theory. It was also, according to radiocarbon dating that emerged decades later, backwards. When researchers began systematically dating megalithic sites across Europe, they discovered that the oldest known stone monuments weren't in the Mediterranean at all. They were in northwestern France, dating back further than anything similar found further east. The diffusion theory didn't just need adjusting, it needed to be abandoned entirely. Megalith building, it turned out, likely originated independently in Atlantic Europe and spread from there, not the other way around. If you're the kind of person who finds it fascinating when an entire scientific theory gets flipped on its head by new evidence, that's exactly the pattern we're about to see happen again, this time with genetics instead of radiocarbon. Go ahead and hit that like button, because what's coming next is even more disruptive than the diffusion debate ever was. So archaeologists adjusted their theory. Megalith building began in the Atlantic West and spread from there. Fine. But a much deeper question remained almost entirely unanswered until ancient DNA sequencing became sophisticated enough to actually address it directly. Who, biologically, were these people? Where had their ancestors come from? And more importantly, what happened to their descendants? The first major genetic surprise came from examining the deep ancestry of the farmers themselves. For a long time, many archaeologists assumed that farming spread across Europe primarily as an idea, carried by trade and cultural exchange between existing hunter-gatherer populations who simply adopted new practices without much actual population movement. Ancient DNA firmly rejected that assumption. Genetic analysis revealed that farming spread through Europe primarily because farmers themselves migrated, moving outward from Anatolia beginning roughly 8,000 years ago, gradually replacing and mixing with the Mesolithic hunter-gatherer populations who had lived across the continent for thousands of years prior. This wasn't simply an exchange of pottery styles and wheat seeds. It was one of the largest demographic shifts in European prehistory, and it happened long before the first megalith was ever raised. By the time the great stone monuments were being built, the builders themselves carried a genetic signature dominated by this Anatolian farming ancestry, blended with smaller amounts of the older hunter-gatherer lineages who had preceded them. These were the people responsible for Stonehenge, for Newgrange, for the passage tombs scattered across Ireland's Boyne Valley. Genetically, they were predominantly the descendants of Near Eastern farmers who had spread across Europe over thousands of years, adapting to entirely new landscapes and eventually developing the extraordinary architectural traditions that still draw millions of visitors today. And then, in 2020, A genetic study of skeletal remains recovered from inside Newgrange itself revealed something that stunned even researchers who study ancient genomes for a living. Buried deep within the central chamber of this 5,000-year-old passage tomb, aligned so precisely that sunlight only reaches its innermost chamber during the winter solstice, researchers identified the remains of a man whose genome carried an unmistakable genetic signature. His parents, according to the DNA, were either siblings or parent and child. This was not an accident of small, isolated communities occasionally intermarrying. This was first-degree incest, the kind typically associated throughout history exclusively with royal or divine dynasties attempting to preserve bloodline purity at any cost. The same genetic pattern later found among ancient Egyptian pharaohs and Inca rulers. Think about what that actually implies about the society that built these monuments. This wasn't simply a loosely organized farming community that happened to gather occasionally for communal building projects. The scale of labor required to construct Newgrange, combined with genetic evidence of a ruling bloodline practicing the kind of extreme intermarriage historically reserved for those believed to possess godlike or semi-divine status, suggests something far more hierarchical and dynastic than most archaeologists had previously assumed. These were not egalitarian farming villages. Somewhere within Neolithic Ireland, an elite class had emerged, powerful enough and sufficiently convinced of its own exceptional status to marry within its own immediate family, generation after generation, in order to preserve a bloodline they clearly believed to be extraordinary. That alone would have been enough to rewrite a meaningful chapter of European prehistory. But it wasn't the biggest surprise still waiting inside the genetic record. The real shock came when researchers turned their attention away from the builders themselves and toward the people who lived in those same landscapes just a few centuries later. Around 4,500 years ago, a new population began moving into Western Europe from the east, originating on the vast grasslands of the Pontic Steppe. The region is spanning parts of modern Ukraine and southern Russia. These were pastoralist herders, culturally and genetically distinct from the farming populations who had occupied Western Europe for millennia. Archaeologists came to associate their arrival with a distinctive style of pottery, bell-shaped drinking vessels found in graves across the continent, giving this cultural horizon its name, the bell beaker phenomenon. For a long time, archaeologists debated a version of the same question that had once surrounded megalith building itself. Did bell beaker culture spread primarily as an idea adopted by existing populations through trade and cultural contact, or did it spread because an actual population of people migrated and settled among, or in place of, those who came before them? In 2018, a landmark genetic study answered that question with a clarity that stunned even seasoned researchers. Examining ancient genomes from Britain specifically, researchers discovered that within just a few hundred years of bell beaker culture's arrival, approximately 90% of the genetic ancestry found in the British population had been replaced, not gradually blended over deep time, replaced almost entirely within a handful of generations. Let that fully sink in for a moment because the implications are staggering. The population responsible for building Stonehenge, for organizing the extraordinary sustained communal labor required to transport bluestones across 150 miles of ancient landscape, was, within a remarkably short span of time afterward, almost completely genetically replaced. Their direct descendants did not go on to become the dominant ancestors of the people who would later occupy Britain. A new population, arriving from continental Europe, carrying steppe ancestry that had itself originated far to the east, effectively became the primary genetic ancestors of nearly everyone who followed. If you're finding this as genuinely stunning as I did the first time I read through the research, make sure you're subscribed, because these kinds of quiet demographic earthquakes are hiding inside ancient DNA all across the human story, and we're only beginning to fully uncover them. This raises an obvious and uncomfortable question. What actually happened to the original farming population, the descendants of those Anatolian migrants who had spent thousands of years adapting to the British landscape, building the very monuments that still stand today? Here, the honest scientific answer is considerably more restrained than sensational headlines sometimes suggest. Ancient DNA alone cannot definitively prove violent conquest, nor can it rule it out entirely. What the genetic record shows with confidence is the outcome, a rapid and overwhelming replacement of ancestry, without conclusively confirming the exact mechanism behind it. Some researchers point toward the possibility of disease, since populations without prior exposure to new pathogens carried by incoming groups can suffer catastrophic mortality, a pattern documented repeatedly throughout later human history during other major migration events. Others suggest a more complex combination of factors, including lower fertility or survival rates among the earlier population, alongside social and economic disruption caused by the arrival of a new, differently organized society, with different subsistence strategies, different metalworking technology, and different approaches to land use. What almost all researchers now agree on, however, is that this was not simply a story of gradual cultural blending. The genetic signal is too abrupt, too overwhelming, and too consistent across multiple independent studies to be explained away as slow, peaceful intermixing. Something disruptive happened in Britain roughly 4,500 years ago, and whatever it was, it left the genetic legacy of the island's original megalith building population as a decisively minority thread within just a few centuries. Similar, though not always quite as extreme, patterns of ancestry turnover appear across other parts of Western Europe during this same broad period, as steppe-derived populations associated with the corded ware and bell beaker cultural horizons spread outward from Central Europe in multiple directions. Iberia, Brittany, Central Europe, and the British Isles all show meaningful genetic shifts during this window, even if the specific scale and timing varies meaningfully from region to region. This means that when modern visitors walk among the megaliths of Brittany, stand inside the solstice-aligned chamber of Newgrange, or gaze up at the towering sarsen stones of Stonehenge, they are, in a very real genetic sense, looking at monuments built primarily by a population whose direct genetic descendants represent only a modest fraction of the ancestry carried by most people living in those regions today. The builders and the current inhabitants of these landscapes are connected by geography and by cultural memory, but according to ancient DNA, considerably less connected by direct unbroken bloodline than almost everyone, researchers included, had long assumed. It's worth stepping back for a moment to appreciate just how different this replacement looked across different regions, because the story wasn't identical everywhere the beaker phenomenon appeared. In Iberia, for example, genetic continuity with earlier farming populations remained considerably stronger than in Britain, even as beaker pottery and associated cultural practices spread widely across the peninsula. This suggests that in some regions, the bell beaker package moved primarily as a cultural and technological network adopted by existing populations, while in others, particularly Britain, it arrived alongside an actual, overwhelming wave of new people. Central Europe shows yet another pattern again, with substantial steppe ancestry appearing somewhat earlier, tied to the preceding corded ware cultural horizon, which itself represented an earlier pulse of the same broader steppe migration that would later reach the British Isles through beaker-associated populations. Piecing together this regional variation has taken years of careful, painstaking comparative work, sequencing genomes from burial sites across an enormous geographic range, and cross-referencing the results against radiocarbon dates, isotopic dietary analysis, and detailed archaeological context. The overall picture that emerges isn't a single simple wave sweeping uniformly across the entire continent, but rather a complex, uneven series of migrations, replacements, and partial continuities, differing meaningfully from region to region, depending on local circumstances, population density, and the specific timing of contact. This doesn't mean earlier archaeological research was worthless, or that the scientists who developed the older continuity assumption were careless or unserious. Archaeology working without direct genetic evidence has always had to rely on indirect signals, pottery styles, tool traditions, burial customs, and settlement patterns. These indirect signals are genuinely useful, but they simply cannot detect population replacement the way genome sequencing can. A newly arrived population can very easily adapt, or even preserve existing pottery styles, burial customs, and land use patterns, while still representing an almost entirely different genetic lineage than the people who came before them. Ancient DNA didn't expose sloppy science. It exposed a genuine blind spot that no methodology available before direct genetic sequencing could have realistically closed. There's also a broader, more universal lesson embedded in this story, one that extends well beyond the specific details of Bronze Age Britain. Population history across the human past appears to have been considerably more turbulent, more disrupted, and more discontinuous than a purely archaeological reading of material culture alone would ever suggest. Cultures build monuments, develop traditions, and construct elaborate social and religious systems, and then, sometimes within remarkably short windows of time, entirely new populations arrive. And the genetic thread connecting past to present quietly, dramatically shifts, often leaving behind almost no trace in the physical, structural record that future archaeologists would eventually excavate. It's worth pausing here to address something important about how this evidence was gathered, because it matters for understanding exactly how confident we can be in these conclusions. Unlike some ancient populations who chose complete and ongoing isolation from the modern world, the Neolithic farmers and Bronze Age migrants of Western Europe left their remains scattered across thousands of excavated burial sites, accumulated over more than a century of careful, methodical archaeological work. Modern ancient DNA techniques allow researchers to extract genetic material directly from skeletal remains, particularly from the dense petrous bone located inside the skull, which preserves genetic material remarkably well even after thousands of years underground. This means that, unlike genetic questions surrounding still living isolated populations, where direct sampling raises serious ethical concerns, these particular genetic conclusions rest on direct sampling of the actual historical population in question. Thousands of individual genomes recovered, sequenced, and cross-referenced across dozens of independent research papers published over the past decade. This is precisely why the scientific consensus here is unusually strong, even though the story it tells overturns decades of prior archaeological assumption. This isn't a single surprising study awaiting confirmation. It's a pattern that has been independently replicated across multiple research teams, multiple countries, and literally thousands of individual ancient genomes, all converging on the same fundamental conclusion. The people who built Europe's great stone monuments were, within a remarkably short span of prehistoric time, overwhelmingly replaced by newcomers whose own ancestry originated far to the east, on the grasslands of the Pontic steppe. There's one more thread worth pulling on before we get to what all of this actually means, because it concerns the fate of the earlier population's culture, not just their genes. Even as ancestry shifted dramatically, certain elements of the older farming tradition didn't simply vanish overnight. Some megalithic sites continued to be used, revisited, and even added to for generations after the population turnover, suggesting that whatever happened between these two groups wasn't necessarily a single, instantaneous event, but rather a more layered process, unfolding across several generations, during which older monuments retained at least some symbolic or practical importance even to newly arrived populations. This is one of the more genuinely open questions still being actively researched. Did incoming Beaker-associated populations simply repurpose existing sacred sites they encountered, adopting monuments built by people they had largely displaced, or does continued use of these sites suggest a more gradual, less abrupt transition than the genetic ancestry data alone might otherwise imply? Answering this fully will likely require combining ancient DNA with much finer-grained archaeological dating of specific activity layers at individual sites, a painstaking process that researchers are still actively working through today, site by site, monument by monument. So, what should we actually take away from all of this, beyond simple surprise at how wrong the old continuity assumption turned out to be? Perhaps the deepest lesson is this: the monuments themselves endure, weathering thousands of years of wind, rain, and changing landscape, while the populations who built them can vanish almost entirely from the genetic record within a handful of generations. Stone remembers in ways that bloodlines simply do not. Stonehenge still stands. Newgrange still aligns perfectly with the winter solstice sunrise, exactly as it has for 5,000 years. But the specific people who conceived of these projects, who organized the labor, who buried their own elite in incestuous dynastic tombs, believing themselves touched by something divine, are not, in any direct genetic sense, the primary ancestors of the populations living across those same landscapes today. There is something quietly humbling in recognizing that. It suggests that identity tied to place, to monument, to shared cultural memory, and identity tied to direct genetic descent are not always the same story, and sometimes diverge from each other far more dramatically than we instinctively assume. The people who live near Stonehenge today rightfully claim it as part of their shared national and cultural heritage. But according to the genetic record, they are, on average, connected to its original builders by a far more distant and diluted thread than almost anyone would have guessed before ancient DNA sequencing became possible. That doesn't diminish the monuments. If anything, it deepens the mystery surrounding them. These structures now stand as something closer to messages left behind by a population that, in the strict genetic sense, largely disappeared not long after finishing the work. Silent stone testimonies to a people whose direct descendants make up only a modest thread within the much larger, more complicated genetic tapestry of modern Europe. Scientists weren't simply slightly mistaken about who built these monuments. They were mistaken about something considerably more fundamental, about whether the story of these landscapes was ever really one continuous, unbroken thread at all. Ancient DNA suggests instead that European prehistory looks much more like a series of dramatic, sometimes abrupt replacements, layered one on top of another, each population leaving behind physical monuments that vastly outlasted their own genetic legacy. The stones remain exactly where they were placed thousands of years ago. The hands that placed them and the bloodlines that followed from those hands tell a far more complicated, far more interrupted story than anyone fully realized until the genetic evidence finally forced archaeology to catch up.